Okay, hi everyone. Another stream today. So let me go onto LeetCode page. We'll be continue our problem solving. Yeah, let me check the quality of the sound. If everything is good. So I have a new camera. So today's stream will have camera enabled. As well, I played around with the settings. So hope everything will be fine. Yeah, let me check how the sound quality is. Awesome. So yeah, I hear myself, everything good. Checking the quality of the camera, everything good as well. Checking the live stream. Is everything right? Not necessarily feel like it's streaming in high quality though. Let's see. Stream is healthy. Let's check analytics. Yeah, I'll keep on analytics and chat in one screen, and the other screen I'll keep on trying to solve the problems. Okay. Have my glass of water across me, and we'll continue our grind. At the moment, as you can see on the screen, I improved my rank by quite a lot with this grinding. So I started at around 700,000, so now I'm close to 478,000 by just solving easy problems, which every new engineer probably can do. Yeah, once we'll get to medium, and sooner or later we'll get into the hard ones, then maybe things will get a little bit trickier. Okay, so for the people which join the stream, I would like to answer how is the quality? How is the sound? Do I need to do any changes? Is everything right? Does camera looks good or lags? Because yeah, I'm new into streaming business, though I try my best to produce like watchable content here. Yeah, as well, I'm thinking, what's my motivation? Why do I do this? So, one reason for streaming, it's like I don't really like solving those problems. And by streaming how I solve them, this is an extra motivation for me to produce content and to do the effort to learn stuff. So that's one of the main reason why I do this. Yeah, let's check where did we stop, because we've got a pretty good result. I mean, we go one by one, and we stopped, I think, invalid tweets, I think, is MySQL. Truncate sentence, so probably count the digits that divide a number. So probably here will be the next one, which we'll try to solve. So yeah. Yeah, count the digits that divide a number. So let's see. Given an integer num, return the number of digits in num that divide num. Okay, so num. Given an integer num, return the number of digits in num that divide num. Okay, so we have the assumption that here we may have multiple digits. So for each digit, we'll need to check if divides num. Not sure I got it. Okay, so so we need to check if num is divided by the digit itself. So let's assume here we have 121. Is it divided by 1? Yes. Is it divided by 2? No. Is it divided by 1? Again, yes. So in this case, we'll have like 2. Okay. So for 7, we have only one digit. It divides by itself, yeah? And the answer is 1. So next here we have 120 or 1248 is divided by 1, yes. Divided by 2, I assume yes, and by 4, probably. And by 8, yeah, probably again. I will not check. I will believe the answer provided by the people here. Yeah, cool. Yeah, let's try to solve it. So we know there are two approaches. We solved many problems with the transforming the digits themselves. So one way to do it's we can divide by 10 and get the remainder, and this will be every digit. That will be one way to solve the problems. Another way, a simpler probably way, it's to transform this as a string and then get the chars. And then after we get the chars, we can parse them again into number. It's a more tedious way, so probably it's taste-wise. So let's go with the simple approach for now. So first thing, we'll need to create a variable where we'll store the counted results. So results in our case will be a number, a counter. So we can call it a counter in our case. We'll need to make it mutable and we'll start at 0 because first we don't have any values. Then what we'll need to do is return this counter. So this will be our result. So for every remainder, we will need to check if the value is if num is divided by this digit. Yeah, okay. So how we'll get each number or each digit in the number? So in order to do that, we'll have a while loop where we'll need to loop. We'll need to loop until we have something in our num, because we will be dividing by 10 every time, and the remainder will be sooner or later we'll get to 0. So yeah, so we have while num greater than 0, and then we'll get the digit. So we can call that digit will be num modulo 10. So this will give us the last digit in num. Then we'll do like num will be equal. Yeah, probably we'll need to mutate it, and in this case we'll need to have a new variable. So let mutable num will be num. So kind of we'll do a mutable clone. So in this case num will be num divided by 10. Yeah, so we get the digit and we divide by 10. So the last division will be 0, because assuming here we have 7 divided by 10, we'll get 0. It's not greater than 0, but yeah, probably we'll need to check if it's greater than 0. Yeah, we'll need to do that until it's greater than 0. Yeah, so we've got this. We've got the digit. Now we'll need to check if the digit it's if the num, or yeah, probably we need to do a clone here. So let's call this with a different name. Digits. Yeah, let's call it digits. So we'll have digits, 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 and num divided, if num modulo digit equals 0, then we'll increase our counter. And that will be the logic of it. That should do the trick. Maybe I may have some problems with the boundaries. Let's try to run it in our head for one example. So let's assume it's 15, wherever. So let's start with 15. So we have digits greater than 0. Yes, it is. We do digit num10, which will be 5. And digits will be equal digits divided by 10, which will be 1. So we'll have new digits will be 1. We check if num modulo digit equals 0. So digits it's 5, 15. Its modulo 0. Counter will be +1. And then the next stage we have the digit being 1. So it's still greater than 0. We do digit num mod 10, which will give us the result 1. So digit will be 1. And then here will be 0. Yeah, everything should be right. I feel like this should work. So yeah, let's run it. Yeah, I'll need to remove this because it will not compile. Already did. Yeah, we've got a wrong answer for case 2. So let's check with 1 to 1. What's the trouble with 1 to 1? And case 3 worked. Case 1.7 worked. No. I don't get it. So we have 1 to 1. Let's try to understand in our head. If we'll not come to a solution, we'll have a simple approach. In this case, we will just use a debugger. So we'll have add it here, create a test for it, and check with the debugger and see. I have a feeling that when we do it here, we kind of mutate it, but it's not clear. Okay, so let's go again. So we have 1 to 1. Modulo 10 will be 1 first. Then we check num divided by digit. Yes, it's divisible. I'm not sure how we've got like 2. So num mod 2. And digits will be digits divided by 10. Which I assume to get the result 12. Yeah. That's the trick. I assume I'll have the result 12. Though maybe unclear. Maybe unclear. Okay. So How can we check that? I mean, I don't have any options here. I cannot use console logs or print lines, so I'll need to check it in my console here. So yeah, probably I'll add just a new file first. Guess how it's called. Count the digits. Number. So let's add this, create a module. Here add our logic. And then let's add a module for tests. And then we'll test solution OK. So let's test that. We'll have a couple of scenarios. So scenario 1 will be 1 to 1. And expected result, we expect it to be 2 instead of 3. And here we'll have like solution and count digits. If you run this example, it shows that left it's 3 and the other it's 2. So I can add the other two examples. I can add the other two examples. So what's that? So it's 7 and 1, 2, 4, 8. So let's add 1, 2, 4, 8. Expecting to have 4. The next one will be 7, expecting to be 1. So yeah, let's go with the debugger and try to understand what's going on there. Maybe I have something I don't understand in a simple code, which happens. I mean, happens all the time. So not an issue. So digit it's 1 as expected, and digits is 12 as expected. And num divided, and num will be 121. Modulo digit equals 0. It's 0, we do counter, it's 1. Next stage, we have digits. Okay, digits it's 1, but digit. Wait, how did we get to digit? Oh my God, that's, yeah. Yeah, it looks like starting a stream after a full day of work, you forget to remove the retard mode. So you do like very simple mistakes. Okay, so scenario 1 and 2, but scenario 4, so scenario 4 is not correct. Oh, yeah, the test itself is not correct, not the scenario. So yeah, it was a pretty easy one. Just yeah, my mind is not as sharp after a day of work, so happens. Yeah, anyway, we had a problem, we solved it. So +1 in our increment. Very likely that will be the algorithm, and I assume it will be one of the fastest, because there is nothing else here which we can improve. We can look a little bit on what's the complexity of this algorithm. And in our case, we'll call this loop for exactly the length of num. So we can call an of n the complexity of our algorithm, which is pretty pretty fast. Yeah, let's move on. We solved this one. So cells in a range on an Excel sheet. I have a feeling this one is not Rust related. Oh, it is Rust related. Oh, and it has some graphics and some examples. So probably it will be a parsing one. Yeah, let's check what this problem it is about. A cell R and C, a cell RC of an Excel sheet is represented as a string of column row. Okay, so column row, where col denotes the column numbers, C of the cell. It's represented by alphabetical letters. For example, the first column is denoted by A, the second by B, the third by C, and so on. Row is the row number, R, on the cell. The rth row is represented by the integer R. You're given a string S in the format col1 row, 2 points, col2 row 2, where col1 represents the column C1, row 1 represents the row 1, col2. Okay, so we've got it. Such that R1 it's less or equal than R2. Okay, so somewhat they are in ascending order. And C1 is less than C2. Okay, so I'm a bit confused. So what do they want again? What do they want from me? So they want return the list of cells X, Y such that R1 is less than X, less than R2. C1 is less than Y. And C2. The cells should be represented as strings in the format mentioned above and be sorted in non-decreasing order. Order first the columns and then by rows. So let's see an example. So if you got from K1 to L2, okay, K1 to L2, in this case, we will have, so pretty much we receive a range. That's the concept. So we will need to have, yeah, I'm thinking how we can divide this stuff. So let me get my pencil and my drawing board and move to the drawing board here. So let's assume we have this example. So we have like K1, L2. So we have the letters of the alphabet. So it will be KL. So they are close. So they're neighbors, not siblings, neighbors. Then we've got starting from 1 to 2. This means we'll need to get all K's from 1 to 2 and all L's from 1 to 2. In our case, our solution will be something like K1, K2, L1, L2. Okay. So we've kind of one thing which I would like to check every time our input will be only 2 letters, and we know by definition that those letters are already sorted. So we'll need to kind of to get the values from K to R. So yeah, let's see another example where we have like more letters from A to F, for example. So yeah, we in this case we'll need to get everything inside. So let's say starting from A1, not like this, like we have A1, 2 points, F1. So we'll have the range from A till F, including values from range 1 to 1. So we'll need to create this range first, and then apply for each element of this range these values. So that will be our algorithm. So this is what's needed from us. I know how to do a range from numbers, but probably we can do if we go like with the ASCII codes. I forgot what's A. It will be like 90 or something till F, which will be 96. I don't know, maybe. If we start at A being here, because we cannot do ranges on strings. Or do we need to? Maybe I can create just I create a vector with the alphabet, and then I'm thinking how we can do it in a more yeah, a better, faster, maybe a more optimal way. So assuming we are at B, so we know that B starts here. We need everything from B till the next one. So we can iterate through this list to create our own range. Yeah, maybe this will work. Okay. So yeah, this is what I'm thinking. So let me try to code it. Do I need this screen? Not for now. So let's create a variable called alphabet. And then here we'll create A, B, C, D, E, F, G, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this will be our alphabet. And we kind of need to collect. Yeah, we'll need to iterate and collect. Yeah, we can go with cause, chars, and collect into a vec of chars. Yeah, probably we can go with bytes as well, but yeah, we'll do optimization later on. So now we have the range of letters. Range of numbers we can do pretty easy. So a thing which we can start doing now, it's parsing our string. So we have like yeah, this is an older version of Rust. We will not be able to do this, but we can do like values results. I don't know. Yeah, maybe cells will be s dot split, and we provide a character, 2 points, and we can collect the result as 2 strings. It will be a vec of strings or strs. Yeah, I'm a bit confused with this approach. What will be the result of split? Either strings or strs. So let's go with strings. Maybe it will work. So we can do like cell 1 will be like cells of 0, and like let cell 2 will be cells of 1. So we've got our cells, but inside our cells, remember, we have a letter and the row. So like the letter A1, for example, and here we'll have like a B5. So we know that here cell 1, the value will be okay, so for this one, we'll need to get the first element. So not like cell, how can we call it? Like column. Because we need to find the starting range and ending range. So let's start call range. Will be cell 1, I assume, of 0. I'm not sure if this syntax works, but if it will not work here, we'll move into our playground in VS Code and we'll check it there. So let finish range will be cell 2 of 0. And we will need to do similar stuff for rows. Row range will be cell of 1, but in this case it will be 1. And we'll do finish row range will be cell 2 of 1. So we've got our starting point and ending point. So I assume here we'll have A, and here we'll have 1, and here we'll have B. Here we'll have 5. So now the algorithm will be something on those lines. So for item in alphabet, I guess for letters, for letter in alphabet, we can do match. Yeah, we'll need a flag here. We'll need to use a flag to know that we started the range or not. So yeah, first let's create a flag. Let range started, which will be false. And then we'll do the following. If letter will be equal start call range, then we'll do like range started equal true. But here we'll need to check first if we didn't start the range already. Yeah, actually it's not possible to start because we have distinct letters in our alphabet. So we start the range. We know that the range is started, and then we can write another if. Yeah, here we'll need to do double equal. If letter will be equal finish row range, finish call range, then we'll make our flag false again, because we enabled and disabled, because we need to cover only a couple. So in between stuff, we know that if range started, if range started, we will do another for loop. So we'll need first to collect our results, which it's expected to be a vec of strings. So in our case, we'll do something like that. We may create like let mutable result, which will be a vec, and we'll return it here. So result. And inside here, we'll need to generate our letters. So we know all the letter. It's either the start or the finish. Yeah, actually, we'll have troubles with the finish part. So we'll need to do it here. Wait. Sorry, I have like too many devices. So we'll need to do it here. After we did our checks, otherwise we'll not include it. So if the range started, then for each letter in our range, we'll need to apply a for loop where we'll create another range starting from start row range, including finish row range. So we'll receive all of our numbers in this case. So we will get our numbers, and we will need to fold, not fold, but map. Maybe we can do it like this. I don't know if this will work though. Let's try. So this will be like a row, and here we can create a format, and inside the format we'll do this. We'll do like first will be our letter, and the second one will be our row. So let's do letter and row. A thing which I'm not sure if this will work, it's the structure that letter. Does it have access to letter inside this map? Yeah, in JavaScript for sure this will work. Though we are not in JavaScript here, so we are in Rust. Okay, so we've got this, and now what we'll need to do, we'll need to collect the values. Let values will be values. Collect back. So I'll be collecting the values, and then I'll need to push those values inside our result. But the trouble is our result expects to have the result vec of string, but here collect will be a vec of strings. And in order to do that, we will need to iterate it and to flatten it. Yeah, it's a ton of code. I'm pretty sure this will not work. I will not even try to compile it. So a thing which I'll try to do, yeah, let me try to run, but this, I should have like bunch of syntax errors. So a thing which I'll try to do now, it's try to run this code, but in VS Code. So yeah, I'll need another problem here. So mod cells in, how is this called? Cells in range. So let's create that. So yeah, I was creating this. Let me copy this algorithm, which is quite big and already has like troubles. But we will fix it, so everything will work in the end. So yeah, let's add our mod for tests. And let's test test solution. Okay. And let's give a couple of examples. I guess simplest will be from A1 to F1. A1 to F1, and expected result to be back of, yeah, this will be like toString. And we'll have like A1. Let me try to write it in this way. B1, C1, B1, E1, and F1. So as a hack, we can do it like this and write toString. So this should work. So we have input and expected, and here we need to call solution cells in range. So at least this, it's good enough to compile, but it will not compile. Yeah, there is a couple of problems though. So split. Yeah, we cannot, yeah, we'll need to make it STRs. So yeah, this is the thing which I didn't know before. So if you do cells of 0, I assume cell 1 will be correct and cell 2, okay. So this is a, yeah, this doesn't work because we need to provide a range. Maybe like that. What's the problem? So it's an str. Maybe that will be the way to do it. Yeah, here I guess, yeah, kind of we cannot do it, so we need to call on the reference. Yeah, we'll need to do the same for this stuff. So this will be like, yeah. Okay, so we've got this part, but we need to pause this, parse it up. So we'll need to do the same thing for the second. Okay, so we have start row range, start call range. So this is a char, but we want to try to compare it as a string, but still it's a one character. So maybe we'll, in this case, we'll need to stringify it for this to work. This is a reference of, so here we'll need to dereference in this case. Or wait a second, why do I need to do this? Why do I need to do this? Because maybe here I will just not use reference and I'll get the value. after pause. So finish, yeah, it's not finish, it's finish. And on type can't call method map on type usize. Yeah, that's right. We need to wrap this into brackets. So we've got this, we've got this, we've got this part, which we need to call again to string. And here we'll need to apply collect function. But collect will tell that we cannot build vex string from string references. But why do we have references? Because we use this. So we'll need to do integer. So now we've got our scenario. So now this works. Okay, so this works from first example, which it's pretty cool. Yeah, tons of code. We'll need to think of ways on how we can optimize it, make it less code, and think of the performance. So we have like K1 and no, it's L1 and K2. So we'll have here L1, L2. Yeah, we don't need this too. K1 and K2. So let's check the example. If this works, I assume it should. No, it didn't. We've got L1, LM, and OPQ. Yeah, because the word, so KL, yeah, that's the trouble. K1 and L2. And then, yeah, this will be upwards. Yeah, let me try to move it up. This should be good. Yeah, indeed it is. Yeah, let's check and see what can we do better. Do we need to collect here? I don't think we need it collected because in either case we do an iterator. So we can just use alphabet and this will be pretty much the same thing. So we'll not need to, we don't need to collect it, we will just create an iterator out of it. What else? Splitting part. Yeah, unfortunately with splitting part we cannot do it otherwise. We'll need to collect and then have these references which are pretty fast. So I guess the slowest part is here. Maybe I'll not do a mapper function here to not have this flattened part. But what I can do here, I think another way to solve this, maybe we'll do a for each. Yeah, we can try to do a for each. What's the trouble? And we have, we'll not need to collect, we'll not need to do anything. So inside the for each loop, we will just push this format. So we'll do result.push format. And in this way, yeah, values here do not do anything. We don't need anything. We'll have our solution, so we'll not do any extra work. What's the complexity of this algorithm? Will be of n, but actually it's less than of n, it will be like not O of n, but 26 multiplied by how many rows? So it'll be, yeah, 26 multiplied by m. But this doesn't grow asymptotically, so this means it'll be O of n. It'll be a linear algorithm. Yeah, let's try this solution and see if this works. Yeah, if it's a lot of code, it's very difficult to write in Rust without the helper of Rust Analyzer as well as the compiler. So you'll need to solve tons of small problems. But with the help of these tools, yeah, looks like we've got a wrong answer. And we miss what? I'm sure I got what do we miss? I feel like we miss a letter in our alphabet. So what do we miss? So yeah, let's check. A, B, C, D, E, F, G, J. Yeah, we miss I somewhere. A, B, C, D, E, F, G, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So yeah, we missed a letter in the alphabet. We missed I. Yeah, let's try this test case. Let's run it. Yeah, we attempted this too fast. Yeah, and H as well. So yeah, my knowledge of English alphabet looks like it's not the sharpest. Yeah, let's submit now. Cool. So looks like it's not the fast solution. So let's check another solution which will be faster. So it's into bytes, and we have like C0, CS char, RS char. Yeah, this looks really, really cool. Yeah, in hindsight, it's pretty much the same algorithm, but instead of using chars, he uses bytes. And with bytes, he has the option to access directly the first. Yeah, because but why does he do it like this? So C0, C1 will be like, oh, so it doesn't care about the 2 points, so he looks right away. Yeah, I think I got it, why this is faster, and I like this a lot. Yeah, if you look at our code, it's same approach, though we do a lot more operation. Like this parsing, we do extra. What else we have? Yeah, the parsing part is extra, so this costs us not to be the fastest. But anyway, yeah, it's good enough. Good enough for us to move on. So yeah, we started to get some interesting problems. Yeah, let's check the next one. So we are up close to an hour, so that's a good result. And seeing a couple of people joining the stream, so I'm not alone. So that's good news. Difference between element sum and digit sum of an array. What? Oh, okay. So we have another like digit transformation problem. So here, so this needs to be in absolute or modulo. So yeah, so we have element sum. So we'll need to sum the elements of the array. At the same time, we'll need to sum the digits of the array. I'm thinking of ways on how we can do that elegantly in one go to not use a lot of extra memory. And I guess we will do it like this. So we'll have something like that. We will still need to have our sums. So we'll have like two sums. So we'll have like two mutable sums. So element sum, I'll call it like this. We'll start at 0 and let mutable digit sum, which will start at 0. Then we'll need to get through each item in nums, or for each number, num in nums. And inside, we'll do our logic to do the summing parts. But the result will be, what's the result? So it will be lm sum minus digit sum. And we'll do an ABS of the result. So this will be our result. Inside, we'll do our digit sum. We wrote the algorithm for transforming a number in digits like a couple of problems ago. So we'll reuse this logic. I guess we'll do simple. So lm sum. First, lm sum will be the sum plus num. But for digit sum, we'll do again our part with digits, where we'll do like let digits will be num, while digits greater than 0, we'll do let digit will be digits modulo 10. Digits will be equal digits divided by 10. And we'll need to sum these digits. So digit sum plus equal digit. Do we care here? Yeah, we'll need to make this mutable for this to work. Do we care here for anything extra? No, I don't think so. Let's try to run it. Yeah, and it worked. It worked. So that one was fast. Yeah, let's check what's the fastest solution. Okay. Yeah, probably we should not call this ABS, and we do some extra, because it's pretty much impossible for, in our case, to have lm sum to be less than digit sum. So we can try to resubmit this one. Yeah, still doesn't work because we use some extra space with this digit. So probably we don't need this as well. We can do it directly here. Yeah, we don't need this, so we have digits modulo 10. Yeah, but I'll get the same algorithm what that person did. So in this case, okay, so we'll not need nums. So num will be num divided by 10. I have troubles to compile this as num is not declared as mutable. Yeah, so this will be num. First segment to num. Is there making num mutable? So yeah, we'll need to make this mutable num. Okay, let's check this one. Is it faster? Is this one faster? No, still that is not faster. So what exactly this guy does, which is faster? And clone. So yeah, he does the clone. I don't know. I mean, it's exactly the same. Exactly the same. Not actually exactly the same, because he does here an iterator. And then in this case, yeah. Hey, okay, anyway. I mean, I'm just spending time on useless stuff. Yeah, let me see if this builds. Yeah, because we need this to be mutable. And leave it like that. Yeah, we submitted, but it's the same result. Cool, move on. Yeah, let's see here. Decode the message. So let's check this one. It's a little bit of explanation here. You're given the string key and the message, which represents a cipher key and the secret message, respectively. The steps to decode the message are as follow. Use the first appearance of all 26 lowercase English letters in key as the order of the substitution table. Align the substitution table with the regular English alphabet. Each letter in the message is then substituted using the table. Spaces are transformed to themselves, so spaces remain spaces. For example, given key happy boy, actual key would have at least one instance of each letter in the alphabet. We have the partial substitution table of H, A, B, P, C, Y, D, B, E, O, F. So actual key would have at least one instance of each letter in the alphabet. So we've got our key. This is a secret. So we'll need to map, like T will be mapped to A, H will be mapped to B, E will be mapped to C. But how do we create this map though? That's the interesting moment. How do we create this map? Because we'll have order and we will ignore, so the first appearance will be the order. So if it appeared the second time, we'll not care. So I guess the simplest way to do this will be to create like a cipher or a dictionary. Let's call it cipher, which will do the following way. So we'll do keys or key. In our case will be chars and enumerate, because we need to know the order of those chars. Then we'll be folding those into a hash map. And we'll have like a mutable accumulator, so usual stuff. And our GH. So yeah, we'll need to include this. So our cipher in our case will be a hash map will be where we'll be mapping a char to another char. But actually, I'm thinking, why do we need enumeration in this case? Because we don't. We may have the letters of the alphabet in reversed order, like we may have like a stack where we have like yeah, we may do it like this. Let alphabet will be A, B, C, D, E, F, G, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Yeah, by the way, this cipher, the first time I saw it, it was in a book by Jules Verne. I think it's called 20,000 Miles on Amazon or something like that. It was a very cool book. I really enjoyed reading it. So it's sort of a detective on a boat where, if I recall it correctly, one brother needs to find who was the killer or something and to deliver a message. And it was encrypted with this encryption. A, B, C, D, E, F, G, I, J, K, L, M, N, O, P, Q, R. Yeah, I miss H again. A, B, C, D, E, F, G, I, J, K, G, H, I, J, K, L, M. Okay, so now that's the right stuff. So we have our alphabet, and we need to do again chars and collect. But in this case, we'll be collecting not as a vector, but as a vecdeq, which is a special data structure which allows you to get from top. So we can pop front and pop from back. So it's more like a queue. So it's used often as a queue. So my idea is we'll be collecting as a vecdeq, and we'll be popping front values for each distinct instance of char in our key. It's told that here we'll have every time we'll have at least one instance of each letter in the alphabet. So I assume we'll have at least number of distinct chars needed for this to work. So we have this. We collected as a vecdeq of chars. Then here what we'll be doing, it's yeah, we'll need to make it mutable because we'll be popping values from it. So here we'll do the following logic. If accumulator has or contains, I forgot the has its in types in JavaScript. So if AC contains ch, and this will be already, I think, a reference, so I don't need to do anything. If it contains ch, we ignore, but yeah. If ac.get, yeah, probably get will be easier. No, this doesn't work in Rust. If let's sum, we don't need the value acc get. Or maybe we can do it like this. If acc.get ch is none, this means we have like a new instance, and we will do acc insert ch and alphabet pop front. So we'll get the letter from the alphabet. And I think we'll need to unwrap this for this to be consumed. For all the other cases, we don't care. And here we'll need to return the accumulator, and we'll get our cipher. So now we've got our cipher. To solve the message itself, we'll be just replacing the values from the map to our new values, and we can do it in the following way. So let message, we can call this as a mutable vector. We'll start as a mutable vector here, and we'll have our no, we cannot have like message and message again. Yeah, maybe we call it output. Yeah, let's call output. So we'll have message.chars. We will do a map. Oh, we don't need actually. So we'll just apply a mapper function. So we'll have a gh, and then we'll do a match. We'll do match of cipher dot get gh, and we'll have two possibilities. If it's some value, then we'll return value. If it's none, then we'll return gh, and this is specifically for spaces. And we'll need to collect everything as a string, or like this. I mean, logically this should work, but I'm pretty sure I have some issues with references and stuff, so we'll be spending some time now trying to figure out. Yeah, already found what's the problem here. So found dot. Where do I have a dot? Yeah, here I have a dot. Yeah, we'll need to include this. So I think it's in collection as well. Deck. Okay, so yeah, we'll need to provide reference here. And reference here. This is found to be a type char. So it doesn't like this, so we'll need to either to make this as a reference, or no, not this, but this as a reference. Cannot return reference to a parameter gh. Okay, let's dereference this then. Runtime error. Yeah, it's a lot of code, and we'll need to use our lib. So let's add pub mod. Okay, decode the message. So let's decode the message. So yeah, we are an hour and 15 minutes already up, which is quite a ton. So yeah, we have struct solution. Yeah, this looks a little bit better. This formatting. One thing which I started to feel the troubles is that usually I thought the moment when an application compiles in Rust, like 90% of the bugs will be caught, so we'll not have troubles. But once I have lately I started to get into these issues, so this is a little bit scary. Because the whole goal of moving to Rust, it's like to write a more reliable code. But if we still, after compilation, manage to make like runtime errors, this becomes interesting. I'd just like to understand what exactly is the trouble here. So LeetCode doesn't show much, so I'll need to use the compiler in this way. So yeah, let's do a test select solution. Okay, make it as a test to be able to run. Let's add some scenarios, and we have two strings here. So I'll do a tuple where I have string 1 to string and string 2 to string, and expected output will be a string as well. So here we'll be doing solution decode message, and input will be like key and message. And let's do the same here, key and message. So let's pick this example. Yeah, let's pick this example. And the message, this will be the message, and let's copy the output as well. So yeah, we've got one scenario so far. Let's run it, and we've got an overlap and a none. So we don't have so we have values, but yeah, okay. Yeah, we'll need to check for this case. Do we have any more values? Because probably there are no values anymore. So simplest way we'll do if alphabet is not empty, or let's do it another way to avoid unwrap. Yeah, actually it's not a problem with the compiler, it's a problem on how did I wrote this code, because a better way to do will be something like this. If let some value, or yeah, let it be value will be alphabet.pop front, then we do this insert, and in our case it will be our value. Yeah, so this would have been the proper way to write this code. So yeah, if you use unwrap, usually you need to either be sure that you'll have a value when you call unwrap, or you'll need to go out for different cases there. Yeah, that's interesting. So we've received this, but we expected this. So that's pretty funny, because I think I got it why it happens like this. Yeah, we'll need to not do only that, but we'll need to filter only alphabetic values, because I think I mapped spaces as well, and this created like a lot of issues. So here we'll have a filter X, or we can call it C. C is alphabetic. So now let's run it again. Now it works as expected. Cool. So we can try to run this code in yeah, I'll need that part here. Yeah, let's see. I'm thinking here, do I need to collect this? Yeah, I need to collect this because I do this operation with pop front. So I'm creating a queue with this vec deck, and using pop front, I will get this A and then B, C till I'll map all letters from the alphabet. So I'll have my cipher. So yeah, let's run. Awesome. So we managed to solve the problem. And let's see other solutions. So we have a hash map, index A as U32. If map contains key L and L is not space, current char from index A and wrap, map insert, index A plus 1. Yeah, I guess it's exactly the same logic. So, I mean, the logic itself, it's overall the same. Nothing else. Why mine it's slower, I don't necessarily understand. So I may try to run again. It's still 1 millisecond. So probably it's some randomness here as well. But yeah, it's fine. I'm satisfied with the result. Do we have time to move for another one where we should keep it short? Yeah, probably I'll stop for the day. Yeah, let's summarize our improvement. We solved a couple of problems, like 4 or 5 or 6 or a little bit more. So we have 88. We started at 84, so it's 4 problems. Yeah, not very good result, not very bad result. We learned a couple of things, so that's the goal. Also, we need to take in consideration that more we advance, the problems will be more and more difficult. So, yep. Thanks everyone for joining in, for liking this content. If you have any suggestions, what should I address or anything else, please write down in the comments. I'll review, answer, and try to be and try to be to respond as fast as possible. So have a nice day, guys.